In this next section, we're going to talk about average rate of change. Okay. The average rate of change of a function, f of x, is the quotient of the difference in the function values of 2 points over the difference of the 2 points. Okay. In other words, average rate of change is f of x minus f of x naught over x minus x naught. Okay. This should look fairly familiar to you. If you think about linear equations, this is almost exactly how we found the slope, meaning change in y over change in x. Okay? So notice for linear functions, this is going to be the same as slope. Okay? In general, it's not quite the same thing as slope. So let's look at two examples here. In both cases, what you'll notice is I've got two functions here where I have 2 points, 1, 1, and 4, 3. Okay? We can clearly see that these are two different functions, even though they have the same 2 points. Okay? Let's look at the average rate of change for each of these functions. Okay? So for our g of x, our average rate of change says that for our 2 points, we're going to take the difference in the function values, means the y values here, so 3 minus 1, over the difference in the x values. And again, notice we've got to correspond the x's with the x's and the x naughts with the x naughts. So the y value of 3 goes with the x value of 4, and the y value of 1 goes with the x value of 1. Okay? From there, we can calculate the average rate. This looks like a 2 over 3. There's our average rate of change for the function g. Okay? Now let's look at the function f. Again, it's clearly a different function, but if we look at the average rate of change, it says that again, if I look at the y values, 3 minus 1, over the x values, 4 minus 1, I'm going to get an average rate of change for f being also 2/3. Okay? So one of the things to keep in mind about average rate of change is it doesn't matter what's happening within the interval. What I'm actually looking at is the slope of the line between the 2 points. And so even though my functions may be very different, their average rates of change could be the same. Okay? Let's look at some numerical algebraic type problems. Given g of x equaling 2x squared minus 5x, we want to find the average rate of change on the interval from 1 to 3. Okay? So similar to what we've just done here, the difference is I don't have the picture. Okay? Another way to say this is, given this function, I want to find the slope of the secant line between my 2 points. Okay? So in this picture here, this is what we call our secant line. Okay? So in this case, my average rate of change for my interval from 1 to 3 is going to look like g of 3 minus g of 1 all over 3 minus 1. Okay? G of 3 and g of 1 we can find. So g of 3 just means I'm going to plug 3 into that function on the top. And we can see I'll get an 18 minus a 15, which looks like 3. And g of 1, when I plug in, looks like 2 minus 5, which is a negative 3. On the bottom, 3 minus 1, I don't need to plug in there, I just need to subtract. So we can see that our average rate of change is going to be 6 over 2, or 3. Okay? Again, what this average rate of change is telling me is that on this interval, this is the slope of the secant line from x equals 1 to x equals 3. Okay. Another way you're going to look at this is for a more arbitrary interval. Okay? So given a function I know that I want to find the average rate of change between 2 points, but now instead of having specific values that I'm looking at, I want to look at 2 arbitrary points that are h units apart from each other. Okay, so t and t plus h. Okay. For my average rate of change, I can do the same thing. So I'm going to set it up the same way. It's going to be my f of t plus h minus my f of t all over t plus h minus t. Okay. Again, we'll evaluate just like we did before. So f of t plus h is going to look like 3 over t plus h plus 2 minus 3 over t plus 2. And this is all going to be divided by, well, when we subtract there, we're just going to get an h. Okay. Of course, we should always simplify our solutions. So here, to get rid of the complex fraction, we're going to cross multiply. So we'll multiply this side by a t plus 2 minus 3 times the t plus h plus 2. Don't forget to distribute the minus sign. All over the new denominator and our h. Here we can notice some things will cancel out. So our 6's go away and our 3t's go away. And we're left with a 3h over h, which those h's will cancel out. So we're left with a negative 3 over t plus h plus 2 times a t plus 2. This is our average rate of change on the arbitrary interval. Now, again, this average rate is basically telling us the slope of the secant line. It doesn't look like it's saying much here, but what this has done is it's given me a formula for any interval of h length. So once I figure out what t value I want to start at, I can always figure out the average rate of change for that interval of h units.